Okay, this is like the second type of problem we're gonna face, and which things are not like in contact directly with the floor, but instead they're hanging from some cables. So, well, from here we need to know that there will be no normal force. Okay, so this is gonna be not gonna be either. So once again, the thing that I told you that we needed to do is just like draw our axis. Okay, some big pair of axes so that we can have an idea of what we're gonna work with. Let me redo this because it's just like very horrible, that curve. I don't like it. Let me redraw this and, okay. Nope. There. Okay, better. I love it. Okay, so from here, what can we notice? First of all, that there are two tensions that are going like this way. T1, it's gonna be T1, and the other one's gonna be more or less like here. This is gonna be T2. And downwards, we're gonna have just the weight that's going down, okay? So, from this drawing, we can know that this angle is the one that's going to be having like 30 degrees, and this angle over here is the one that's going to be having 60 degrees, okay? Because of angle properties. If you don't know this, I really encourage you to check all your notes on trigonometry and geometry and so on, so you can know where this is coming from. Okay, so, well, we know that, and we need to know now settle the equations of everything. So let's start with doing like the sum of all the forces in x. I know that the tension one, cosine of theta, it's gonna be theta one plus, not actually minus because it's on the negative y, minus t2 cosine of theta 2. It's gonna be 0, 0 because it's not moving. And something very similar is gonna happen in y, and that's gonna be t1 sine of theta 1 plus, because both of them are over the on the positive part of the y-axis, so that's t2 sine of theta 2. It's gonna be, no, minus, because negative is going down, minus the weight. That thing is gonna be equal to 0, okay, because it's not moving. So from here we now check that we have two variables, and we have two equations, and we can just settle the equations and solve them manually. But the thing that I just like to do, because if you don't have the cool calculator, you need to do everything by hand. Well, just like solve for one variable and plug it into the other one, so it's just like far much easier. And well, let's check this. So tension 1 from x as tension 1 cosine of theta, it's going to be equal to tension 2 cosine of theta 2. So from here I'm going to solve for, I don't know, t1. So t1 is going to be equal to t2 cosine of theta 2 over cosine of theta 1. Okay, so this we're gonna plug into the y equation, and which is gonna be, let's recap it over here, t1 sine of theta plus t2 sine of theta 2 minus w, that's gonna be 0. Okay, so from here I'm just gonna substitute in t1, so I'm gonna be left with, this is gonna be theta 1, sorry, this is gonna be theta t2, it's gonna be cosine 2 times tangent 2 times tangent of theta 1 plus tension 2 sine of theta 2 minus weight is gonna be 0. From here we solve for t2, and it's gonna be cosine of theta 2 theta tangent of theta 1 plus the sine of theta 2. All of this stuff goes downwards of the weight. Okay, so we just now substitute values here. We know that the cosine of 60 tangent of 30 plus the sine of 16. All of this goes downwards of an 8. That and that's gonna be 6.92 newtons. Okay, so from there we just have tension 2, and this is one of the results I'm being asked for. So here it is. And let's now compute the other tension. That's gonna be tension 1, and I don't know. Let me use an orange. So from there, I know I have T1 is gonna be T2 times cosine of theta 1 over theta 2, sorry, over cosine of theta 1. So that's going to be 6.92 times cosine of 60 over the cosine of 30. And that was supposed to be 4 newtons. And that is everything you have to do for this problem.